what's different between the two? Well, first and foremost, let's understand here that OSPFv3 is built on the standards and the greatness of OSPFv2. So we didn't recreate OSPF just for IPv6. We enhanced it. We added support for IPv6. So in this case, we don't have to relearn everything about OSPF. A lot of the knowledge we have from OSPFv2 is going to translate and merge into OSPFv3. For example, the stub areas that we learned about, the totally stubby areas, the not so stubby areas, all of that still applies here. The default routes, the passive interfaces. We don't have to relearn all of that. Likewise, the hierarchical structure, as we see here. We're still dealing with a multi-area OSPF design, especially if we want to scale our infrastructure to support a large number of end users, a large number of routers, still have the concept of area border routers, still have the concept of autonomous system boundary routers. All of that still applies here. Therefore, we're going to be dealing with a lot of the same LSAs. But in order to improve on the LSA flooding, in order to make OSPFv3 better, they've changed some of the ways that the LSAs behave. So we'll see that a little later in our discussion. And we'll look at the differences between OSPFv3 LSAs and OSPFv2 LSAs. We're still using the same shortest path first algorithm, Dijkstra's algorithm. Nothing's changed there because all we're doing is using IPv6 networks now and putting those into the overall calculation. Cost is still the same. The way it's calculated from one point to another, still the same. Still using the reference bandwidth value. So none of that has to be relearned. We have a router ID. Now the router ID in OSPFv2 was an IPv4 looking address. How was it determined? First of all, the router looked for the router ID command. Is the router ID command configured? Yes. Use that 32-bit address that looks like an IPv4 address as the router ID. If you did not manually configure it with the router ID, then the router looked for loopback interfaces. Are there any loopback interfaces with IPv4 addresses? If there are, use the IPv4 address that is the highest amongst all the configured loopback interfaces as the router ID. And if there were no loopback interfaces, then the router looked at what? It looked at the physical interfaces that are up at the time the OSPF process started. And from there, it determined that the highest IP address amongst those physical up interfaces would be used as the router ID. Well, when we're dealing with IPv6 and OSPFv3, we are still dealing with a 32-bit IPv4 looking address. So it looks like an IPv4 address, it smells like an IPv4 address, it tastes like an IPv4 address, yet it's not an IPv4 address. It's a 32-bit number in dotted decimal notation. So it looks like it, but it's not an IPv4 address. So what we're trying to say here is that you don't have to be running IPv4 at all on your router. You don't have to be routing IPv4. You just have to create an address that looks like an IPv4 address and use that as your router ID. So for example, when you start the OSPF process for OSPFv3, you'll put in a router ID manually with the router ID command. And it's going to be in dotted decimal notation, just like an IPv4 address. However, if you don't do that, and there are interfaces with IPv4 addresses, then OSPFv3 will go and look for loopback interfaces, use the highest IPv4 address off of a loopback interface as the router ID. And if for some reason there's no loopback interfaces, go look at the physical interfaces. Are there any with IPv4 addresses? If there are, take the highest IPv4 address amongst those interfaces. So it's still using the same process. Still looks like, smells like, tastes like an IPv4 address, but it's not. So you don't need IPv4 running on your router. You don't need IPv4 addresses. You simply hard code it with the router ID command, and away you go. Adjacencies. are formed with link local addresses. This is a very important concept. Very important concept, because since we are now forming adjacencies with link local addresses, we have to understand the link local addresses that are on those local links that we're attached to. And we have to understand how to get to those link local addresses, who owns those link local addresses. As a result, there is a new LSA type for OSPFv3 to help the routers learn about and understand these link local addresses that are out there on our local links. So we'll talk about that a little later. In addition to that, the next hop is always going to be a link local address. So keep that in mind as we're going through our discussion here. We will be enabling OSPFv3 on a link-by-link basis, so we no longer use the network command to enable OSPFv3 on a whole bunch of interfaces at the same time. You go to those interfaces, you enable it one by one. And lastly, we are using different multicast addresses with OSPFv3 than we did with OSPFv2. With OSPFv2, we had the 224.0.0.5, which was the all OSPFs multicast address, all OSPF routers multicast address, and then we had 224.0.0.6, which was the designated router, backup designated router multicast address. Well, in this case, remember that we are dealing with forming neighbor adjacencies on these local links. So we're going to be using the link local multicast address that is available with IPv6. It starts with FF02. And then we are going to specifically send hello packets to :5. So FF02 :5 is the OSPFv3 multicast address, or link local multicast address, that's used for hello packets. That's how we're going to form neighbor adjacencies. And then we have the FF02 :6 multicast address, which is being utilized by the routers when they want to communicate with the designated router and backup designated router. So they preserve the very final value that was in the OSPFv2 multicast addresses, 224.0.0.5, 224.0.0.6. Well, here we see FF02 :5 and FF02 :6, which are used for the same reasons.